All right, guys, today we're going to start some new stuff. The point from now until the end of the course is to prepare you for university. So one of the first things I ran into my first day is my prof using IJK notation for vectors, and I had never seen it before. Neither had many of the other students in the class, but I was taught things as if I should know it immediately. It's not very hard, but it sucks if you run into it and you've never seen it before. So let's do that. We're going to do something called dot product, which is a way of multiplying vectors. It's effectively stuff like work when you do force times distance, but if they're not in the same direction, you do force times distance times cos theta. You could also just do a dot product with force times distance. Any situation where you're multiplying two things that should be in the same direction if you want a maximum amount, and you use like a cos theta to figure out how much they're in the same direction, that's the sort of place you'd use a dot product. It's sort of you're multiplying one of the vectors by the projection of the other vector in the same direction. So we'll talk about that in a sec. But first, we should talk about another way of thinking about vectors. And so first guy we got is we've got this lovely graph. It's got some vectors, some things with magnitude and direction. A plus B equals C. You're used to that. But we're used to more saying like A has a certain magnitude and it's got a certain angle, like so many degrees north of east or something. Today, we're going to talk about another way of representing it. So the obvious other way you might represent this is just figuring out the x and y components of this guy. So you could say, hey, A is equal to, it's got an x component of, looks like 5 to me, and a y component of 1. That gets all the information we need too. We could either give a magnitude and a direction, or we could just give the x and y components of it, and we have the same information. And we can do the same kind of things with it. With B, it looks like it goes over 1 and up 4. So that would be, have an x component of 1, and it'd have a y component of 4. And C would have a, looks like a x component of 6 and a y component of 5. Now, interesting thing to note, adding vectors is super easy if you've got them in coordinate form. Notice how it was like a serious pain in the butt before, like we'd go and do like, I don't know, maybe cosine law or something, figure out this angle if we wanted to find this guy. Be a pain in the butt. We'd have to figure out some angles, but if we want to figure out what C is and we know A and B in coordinate form, we can just add them up. So if we do 5 plus 1, it's just 6, and 1 plus 4 is just 5. So adding vectors is remarkably easy if you've got it in this sort of coordinate form. Now I want to also show you, you can also write it a different way. So the other way you can write it is this IJK garbage that I was exposed to my first day in honors physics. You just write it, this is the same as 5I hat plus 1j hat. And this is equal to 1I hat plus 4j hat. I is kind of your x component. J is your y component. And just on this grid right here, a unit vector, a vector of length 1 in the x direction is I hat. That is known as I hat. And a vector in the y direction, a unit vector, a vector of length 1 in the y direction is known as j hat. And you will probably get very familiar with these guys once you start doing linear algebra. So just unit vectors in that direction. So it kind of makes sense. You've got 5 kind of unit vectors in the x direction plus 1 unit vector in the y direction. Remember, you'd add them tip to tail. So it'd be like over 5 up 1 is kind of what they're saying. And that's the same as A. So just another way of looking at it. There. So this guy would also be 6 times I hat plus 5 times j hat, if you were to add them like vectors, like this kind of thing. Tip to tail, and then the resultant is from the first tail to the last tip. And that is the new form of vectors we'll get used to. Notice adding is super easy. We'll see what else we can do with it next time.